You ever see a map of the world's oil reserves and just stop and think, wait a minute, why is so much of it right there? It really does feel like one little corner of the globe totally hit the geological jackpot. Well, today, we're going to dig in and find out exactly why that is. I mean, really think about that number for a second. We're talking about 65%. That's more than half of all the easy-to-get oil on the entire planet, all crammed into this one region. So, what's the deal? Was it just some crazy coincidence? A lucky roll of the geological dice?
Nope, not even close. The real answer is way more amazing. It's this. Well, it's like a perfect geological recipe, one that took 250 million years to cook. And today, we are going to break down every single ingredient.
So, what's in this incredible 250-million-year-old recipe? Well, it all boils down to 4 critical ingredients. And the crazy part is, they all had to come together in exactly the right way at the right time. So here's the game plan. First up, you need the raw materials, which came from an ancient ocean. Then you gotta have the perfect container to hold it all. Think of it like a spongy rock. Ingredient 3 is a super tight lid to keep it from getting out, and the finishing touch, a gentle squeeze to bring it all together. So let's get started with ingredient number 1. It's funny to think about, but it all starts with life. Yeah, millions and millions of years ago, the stuff we now call black gold, well, it was actually a living, breathing world of vibrant green and blue. Let me introduce you to the Tethys Ocean. See, long before there were any deserts, the entire Middle East was covered by this warm, shallow tropical sea. It was the perfect nursery, just teeming with life. We're talking trillions and trillions of microscopic critters, like plankton and algae. It was basically a massive, planet-sized biological soup. Okay, so what happened to all that life? Well, when these zillions of tiny organisms died, they sank down to the ocean floor. And here's the key. The water down there had very little oxygen, so they didn't really rot away. Instead, they just piled up and got buried under mud and sand. And then, for millions of years, they were just slow cooked by the Earth's internal heat and immense pressure until they transformed into the gooey black stuff we call crude oil. All right, so you've cooked up a bunch of oil. Great, but that's only step 1. Now you've got a problem. Where do you put it all? You need a good container. And this is where ingredient number 2 comes in. As it turns out, the geology of the Middle East had the perfect storage solution all ready to go. These huge, thick layers of porous rock, stuff like sandstone and limestone. Now, don't picture a giant underground cave filled with oil. It's not like that. It's more like the oil is held in all the tiny little spaces between the rock grains, exactly like water in a giant sponge. And listen, this is a really important point. Lots of places around the world have these kinds of sponge rocks. But in the Middle East, they're on another level. They're incredibly thick, and they stretch for miles and miles without any breaks. And that continuous structure is what allows for these absolutely massive oil fields to form, way bigger than what you'd normally find. Okay, so let's recap. We've got the oil, and we've got the giant sponge to hold it. We're all set, right? Well, not quite. There's a huge problem. Oil is light, it's buoyant, and it really wants to escape. I mean, think about it. Oil is lighter than water. So why didn't it all just float up to the surface and disappear? What stopped it from just seeping out of the ground over millions of years and being lost forever? The answer, and this is ingredient number 3, is something called a salt lid. The whole region happens to be covered by these incredibly dense, thick layers of salt and other impermeable rocks. Geologists call them cap rocks, and they are the perfect airtight seal. This lid essentially put a cap on the bottle, trapping all that oil and gas in the spongy rocks below and locking it away for millions of years. Okay, recipe check. We have the oil, we have the container, and we have the lid. Now we just need the final ingredient, the masterstroke, the finishing touch that gathers all that scattered oil into huge, easy-to-get-to pools. And this final step is all about tectonic activity, the movement of the Earth's crust. Now, in most places, this is a pretty violent process. Plates smash together, shattering the rock layers and creating escape routes for any trapped oil. But not here. The Arabian plate experienced something totally different. It was more like a slow, gentle squeeze. It didn't break the rocks, it just folded them. And this gentle folding created these amazing, huge, dome-shaped structures in the rock layers called anticlines. So as the oil naturally tried to float up through the sponge rock, it would hit that salt lid and get trapped. And where does it go? It all collects at the very top of these domes, creating these unbelievable, super concentrated pools of oil. The result of this is just mind-blowing efficiency. Because all the oil is gathered together in these perfect domes, you can just drill one well right into the top and tap into a colossal reservoir. That's why a single well in the Middle East can often produce as much oil as hundreds of wells in other parts of the world. It's just incredible. So, let's put it all together. You take the primordial soup from the Tethys Ocean, you pour it into a massive sponge rock container, you seal it with an airtight salt lid, and you give it a gentle squeeze for a few million years. What do you get? You get what everyone in the business calls easy oil. And the difference between easy oil and, well, hard oil is night and day. In the Middle East, you've got this conventional oil. It's just sitting there in big liquid pools inside that porous rock, ready to be pumped out. Compare that to a lot of the unconventional oil in places like the US or Canada. There, it's trapped inside solid shale rock or all mixed up with sand. Getting it out is a whole different ballgame. It's way more difficult and way more complex. And this isn't just a geology lesson. The economic impact is absolutely enormous. Because of this perfect geological setup, the cost to pull 1 barrel of oil out of the ground in the Middle East can be just a few bucks. Seriously, that's a tiny, tiny fraction of what it costs to frack shale or process tar sands. And that simple fact, that one geological advantage, has literally shaped our global economy for the better part of a century.
So there you have it. It really wasn't luck at all, was it? It was 250 million years of perfect coincidences. The ancient ocean providing the life, the massive spongy rocks for storage, that perfect salt lid to trap it all, and that final, gentle squeeze to bring it all home. It's not just a collection of rocks. It's a geological masterpiece.
And that brings us to one last pretty big question. This incredible geological gift took 250 million years to make, and we are burning through it in what amounts to a geological blink of an eye. So you have to wonder, what happens next? What happens when it's all gone? Something to think about. Thanks for joining me for this explainer.